Okay. So as we were discussing about this one. So work can be what? Positive, negative, and zero. That's what we saw Friday. Okay. So if there is a box here, we can easily identify, okay, force and displacement and all that area. We can find out area under this curve. But if it is not like exact shape, if it is like shape which is shown in this graph, like some random shape. So what we'll do, integrate throughout the limit. We'll integrate, we'll take a strip here. And we will find the area of that strip and we will integrate throughout the limit of starting limit is x1, ending limit x2. So we'll just roll over the limit. That is our work, integration of force, cos theta, and small area, that is we are taking as ds, small displacement. There is rectangular in form of vector, that is integration of f vector dot ds vector. That's what you already know. So f is the function of x. F is the function of x dx. Small, like we're taking small distance. Okay, so here W is total work done, and F is resultant force. The force, which is like which we applied a force and it's moved, so, which gives result. Okay, so let's see this question here. It's very easy. A block of mass 2 kg moves 2 meters. F is 15 Newton. What is the work done by applied force? So what is the work done by applied force? It's very easy.
W is equals to Fs.
Yeah. You can tell me orally answer. No need to calculate this. Fs will be 30. Simple. Okay, what about this one then? Normal force exerted by table, exerted by table. What would be normal force? You know normal force, right? What is normal force? What do you mean by normal force? Okay, let me tell you then. Force which is perpendicular to the surface. That is normal force. Weight mg is always perpendicular to the Earth's gravity. It's moved towards the gravity. You have to remember these points. Normal force always perpendicular to the surface only, not perpendicular to anything else, on surface. Suppose it's at incline. So if we want normal force is perpendicular to the surface. But weight towards mg, it's towards the Earth's gravity. Okay. No, normal force exerted by the table, they're saying, not the box, by the table. That is 0 because
no vertical displacement.
Oh yeah, how did it? Yeah. Anyhow, yeah, you know, right? Like it's not moving up and down. The table is not moving up and down, and it's not moving anyhow. Similar way, force due to gravity also 0, because there is no like towards the gravity or against the gravity. It's neither like positive or negative. That's why it's 0.
Yes, sir.
Yeah. And what about this question? Like force is given 75, theta is 30 degree, and displacement phi. You can give me oral answer. No need to use pen paper.
Sir, W is equals to F cos theta.
Hmm. Answer. 75 into 5 into cos 30. Don't use pen paper. Try yourself without pen paper. What is it? Yes, what is it? What is cos 30?
Sir, root 3 by 2.
Hmm. And 75 into 5 into root 3 by 2. How much? Just keep it root 3 as it is. Remaining thing. Come on. You should be like quick in oral calculation because it will be helping you for solving numericals.
Root 3 1.7.
That is okay. 1.72 correct. Fine. What about 75 into 5 by 2? Still we have root 3 by 2, right?
Yes, sir. 63.7 work then.
Okay.
Oh,
No problem. You have to be quick in oral calculation. It will be helping you. Just to see like simple way 75 into 5, into root 3 by 2, it's 5. Okay, so 75 into 5, we can say 35, 37, 375 into root 3 by 2, 375 into divided by 5. Sorry, 2. Okay, 300, 150, 70, 35, 150 plus 35 and 2.5. If we add this and into root 3 1.73, and we can get this. It's okay, like sometimes we cannot do all that. Okay, let's go for next thing. Next question. Okay. Force is given, this one, 6i cap plus 4j cap Newton, and displacement is 3i cap plus 4j cap meters. Calculate work done. Here's the area.
sir, उसको क्रॉस प्रोडक्ट निकाल दें.
आई मल्टीप्लाई करेंगे, जे मल्टीप्लाई करेंगे. Yes, Vishwanath. You also have applied for JEE exam this term, Vishwanath. Yes, area. What's the answer? Just multiply those two. 6, 3 for I and 4 into 4 for J. So what do you get? 6 3 is 18 plus 4 plus 4. So 4 4 16 30 34. Okay, try this question then. Here's the area. You got 34. Yes or no?
Yes, sir.
Okay. Okay then. Let's find for this one. This is some basic question first. Then we can go for some exam question. So what's question here? It's moving from 1 to 5. Find the work done in moving 1 to 5. So find out for first, second, third, and fourth. This all are in Newton, is in meter. Come on, tell me answer. You can calculate this orally. Area under curve will give you work done. Force into displacement. Yes, Vishwanath, are you with us or not? Might be. Okay. Yeah, the area. What your answer?
Sir, doing.
See, we can do this quickly. Just 10. Okay, no, you try first. No problem. If I give answer, then not a problem. Yeah, can you hear me right?
Yes, sir.
Okay, I got disconnected. Fine. Yeah. So I didn't hear your answer. What's your answer?
Not content.
Okay, see. Then I'll tell you. How much distance you took for the first part?
1 meter.
1, sir.
For second part? For second part? Come on, speak up, speak up.
1, sir.
One. For third part also? One, I think so.
Yes, sir.
Sir.
Fourth part also one. That answer is done. Then how much time you need? See, first, second, and third part are similar. Plus 20, minus 20. So it will be cancelled. So we are left with first and fourth. That is answer is 20 Newton. That's it.
Sir.
Right. That's it. 20 Newton. Now, in fifth question they gave f is a function of x. In that equation is 2x plus 3x square. Even I want this answer to be orally. Now you don't need to use pen and paper. What you have to do? They have given equation. That means you have to integrate this. Come on, just tell me integration value. Then you can substitute value with your pen and paper, fine. But at least you tell me integrate value. Quick. I want quick answer. Yes. Don't use pen paper. Come on.
So 4x minus 3.
4x minus 3. Think again. Yes, Vishwanath. What do you think? Don't use pen
2x
paper.
square by 2, sir, plus 6x s cube by 3, sir.
You say like a 4x square by 2.
So 9x plus 2.
Wait. What do you say? 9x plus 2. And what about if he said like 4x square plus 4x by 2 plus? Say that again.
9x cube, sir, by 3.
Oh, minus. Okay. And what was your answer? Idea?
So
Okay, no problem. Now see, if it is like integration, right? Anyhow, we have to integrate this by the limit x and x2. So it will be yes, 2x square by 2 plus, it's 3 already there, 3 x cube by 3. So it will be x square plus x cube. Now let's substitute values. For values, you can use pen paper. Upper limit is 2, lower limit is 1. So that is 4 plus 8 minus 1 plus 1, that is 2. So 12 minus 2, which is 10 is the answer. Let's see. Yeah, 10 units. So in integration, we are increasing, right? Increasing terms. Understood, both of you?
yes, sir.
Okay. Okay, where did you find the mistake? What mistake you did? Check. See, we are not seeing here right or wrong, but we are finding mistake, and so that we won't repeat that mistake. because small mistake costs more. Okay, so what was your mistake, the area?
Sir, I differentiated instead of integrating.
Oh, acha, differentiated. And what about you, Vishwanath? What was your mistake? Or you got the same? Mm-hmm. Okay, so let's go for next question then. Yeah. So what they're saying, a body moves along the circumference of circle, that is r equals to 2 meters. What is the work done by force of 15 Newton on a body at angle 60 degree to the tangent at any point on the circle? Now what they're saying, they're asking what is work done by the force 50 Newton on a body that is at 60 degree to the tangent at any point on the circle. Yeah. So what is it? So what will you do here? Simple. Come on, solve this. Yeah, you can use pen paper here. When when there is an actual class day, regular class, you both are not speaking up. Why is it so? You're like shy type of guy or what? Or it's crowded so much?
Sir, introvert.
Introvert. Okay. Then at least you can type in a, like a chat box. Okay, you got answer. You then whatever it is, blah blah blah. Nobody's going to eat you, man. Because see why I'm interacting so that I can understand. Okay, yeah, this boy understood. This girl did understood. This girl understood. Or somebody needs something again. Then I will identify. Okay, what should I make you understand? Because if you don't speak, I think okay, yeah, you understood. That means, or you are not listening. Only two things we can understand by silence. Right, Vishwanath?
Sir,
Yeah. Okay. Yeah. So back to the question. So you both bachches need personal attention. Yeah. So then only you can speak. Achhi baat. Good. Yeah, but at least you are doing right that time also in regular class. You're doing right. Numericals, whatever I'm giving.
Yes, sir.
Okay. Good. Okay. Let's see the solution, or you want to give answer first? Yeah, you give me answer first, then we'll see the solution. Come on. What's your answer, Dairya? And what about you, Vishwa? Oh, still finding. It is very easy. See, simple one-step answer. As we want to know distance, so circumference will be the distance here.
So 219.
219. It's 94. So distance is as body moves along a circle. So circumference is 2 pi r. R is the radius that is given in question. Force into this distance, and cos theta is 60 degrees. 60 is half. That's it. So multiply all 15 into half into 2 into pi into 2 meters. This all are SI unit, right? Newton, and this is meter, yeah. 30 pi. So 30 means pi. 3.14. So around, yeah, 94.2. Is my audio clear, or like it's breaking in between? Because I see here unstable network.
So clear.
All right. Because I got notification as unstable network. Okay. So you understood this one? What we did, just simple, like circumference, right?
Yes, sir.
Okay. What about you, Vishwa?
Sir,
Shall we go for next now? So these were some basic questions of different type. Let's see conservative force. See this word, like it's this things what we are studying here. It's most important for the questions which we are going for next part. So conservative force, a force is said to be conservative if work done in moving a particle from one point to another point depends only on this path. Means if I'm moving this box from here to here, or let's draw it vertically, or anyhow, if I'm moving this box A to B, it just depends upon point. It doesn't depend like how we are moving. We are taking here, then we are moving there, we are moving there, we are moving here. How we are moving and bringing it at the end, this is point B. It doesn't matter how we are going. What's the path followed? It matters final and initial point. Because that's what displacement, right? That is the displacement. If we say that is the work done in moving from point from one from a like first to end point, first point to another point. That is the work done in moving a box. So force applied and it displaces. And where, however it is displacing, that is not the path. Like we are not worried about the path followed. We are just worried about where it is moving. That's why we wrote here one point to another point. That is conservative force. Non-conservative force, which requires or which follows the path. Same example, how where it is moving, it depends. Okay. So forget about the conservative force and all, but tell me which will be conservative, displacement or distance?
So displacement.
Displacement will be conservative. What about distance?
Non-conservative.
Okay. Fine. So WD means work done equals to mgh. So that will derive here also in energy. Energy we know, capacity to do work. And energy is scalar quantity, dimension formula, you know, right? Dimension formula is similar to work. Similar to work. See, work, energy, power, all are similar. Almost they depends upon each other. If you say work is what force applied on a body and it displays from a position. That is work. So how much capacity some object has to displace? That is energy. And at what rate he is doing that work? That is power. This all three are related to each other. Force applied on a body, it displays, and how much capacity is having to do that work, that is energy, and at what rate he is doing that work, that is power. That's why we say rate of doing work. Here we say capacity to do work. Fine with it. Unit similar. And for this, we are going to study only mechanical energy. In mechanical energy, kinetic energy, and potential energy. Kinetic energy possessed due to its motion. Potential due to its position. And this one we already derived before. 1 joule equals 10 to the power 7 ergs. How to get this? You know this conversion, right? Unit conversion?
Yes, sir.
Good. If not, then I can explain, or else let's move to next. Okay. Now we are deriving this kinetic energy half mv square. End product we should know. This end product we should know. Acceleration equals to this formula we know. V square minus u square equals to 2as newtons. Third equation, Newton's law of motion. Third equation. So force equals to mass into acceleration into displacement will give you work done. So acceleration we derive, we just substituted with this value here. Then displacement cancel, and we are left with m by 2 v square minus u square. Now if u is at rest, means initially we are at rest, so u will be 0. If not, then it will be half mv square minus mu square. Okay. So that is change in kinetic energy. That's what half mv square will give you final kinetic energy. Half mu square will give you initial kinetic energy. That is what work energy theorem. That is what we are going to talk about. That is work energy theorem. So let's work on moving for one particle. This is W1 is for particle work done on one first particle, work done on second particle, like that, work done on nth particle. Same way, force applied on first particle till nth particle. Similar way, x for first particle, displacement for the nth particle. So all these are work done. Total work done, W will be summation of force and delta x. N equals to 1 to infinity, whatever number. Okay. So here we can integrate here, and as usual, how we did this one previously. So integration of force into displacement with the limits a to b, means upper limit and lower limit both. Let's try this question then. Come on. A 50-gram bullet is accelerated to the rifle barrel 75 centimeter long at a speed of 720 meter per second. Calculate the average force exerted on a bullet while it is accelerated using work energy theorem. Okay, so mass is given. Calculate average force exerted on a bullet while it is accelerated. Using work energy theorem. That is half m square minus half mu square. Yes. What about your answer? Are you doing it? Dhairya, Vishwanath?
Yes.
Yeah, so quick in muting and unmuting.
Sir, initial velocity would be 0.
Yeah, what happened? Why this notification came? Upgrade to Pro. Okay, let it be. I think so. This meeting will end in 10 minutes. Okay, no problem. After that, we have chemistry class also, right? Okay. It is initial. What was the answer? Oh yeah, you say initial velocity 0. That means this is 0. Yes, obvious. Remaining thing, it's given. Come on. Yeah, what's your answer? Vishwanath?
180 newtons.
180 Newton. Okay, and Dhairya?
It's the same.
It's 18,000 Newton. Yeah, 36 into 5, which is 180 into that 0 zeros, that will be 18,000. Yeah. How you got 180? Where did you miss some zeros? I think so. You didn't convert this 72 centimeter. Have you converted this centimeter to meter?
Yes, sir.
Then where did you miss 2 zeros? Find out. Tell me, where did you miss 2 zeros? Yeah, where did you miss 2 zeros? Tell me.
So while converting the
Which unit? Like
meter to
you didn't convert that one. Okay. What about you, Vishwanath? You didn't find a mistake?
So calculation mistakes, sir.
Yeah, that's okay. That's what I'm asking. Where did you miss that 2 zeros? See that? Tell me. Okay, you find out. Till then, let's go for next question. 2 masses, 2 kg, 3 kg pulley. It is inextensible string. Okay, not stretchable. The masses are held at rest beside each other and then released. Find the speed of each mass at the instant they both are at 0.05 meters. Okay. So 2 masses are there. There's a pulley. Okay. You need some hint, or you will do it? Yes. Any progress? Dhairya? Vishwanath? Any progress? Are you stuck somewhere? If you're stuck somewhere, I can help. Yes, guys, you're doing it. It took more than enough time. Okay, then let's solve. So what they gave, two masses, 2 kg and 3 kg in extended string. So find the speed of each mass at an instant. They both are at 0.05. So in short, this if this object, this mass is more, right? 3 kg is more. So obviously it will be moving down. Then 2 kg will be moving up. So work done in form of kinetic energy. So kinetic energy is changing here. Work done here it is in form of potential, stored energy, that is stored, mgh. And here kinetic energy, as we will use that, half mv square. So here it is kinetic energy is due to both, right? This one as well as this one, m1 plus m2. And in this case, potential energy will vary about height. So subtraction of those masses into gh, difference of those masses. Here change in kinetic energy will be due to both 2 kg as well as 3 kg. That's why we are adding here. Here we are subtracting. There is gh, half m1 plus m2 v square.